Hi, so we'll solve this problem today. In this problem, we have two blocks that are connected through a massless string. We're assuming that the string is massless, and there are two blocks. One block has mass capital M, which is given as 3.3 kilograms, and the small block has mass 2.1 kilograms. Now, the surface is frictionless, okay? And in the first part, we have to find the acceleration of the blocks S and H. And in the second part, we have to find the tension in the cord. Now, in these type of problems, the first thing you should know is that the acceleration of the two blocks is the same. Okay. So the reason is because if this guy moves a distance, let's say 1 centimeters, this will also move a distance of 1 centimeter in the same time. So if the string is not extendable, it's not like a rubber band, then they both will have the same acceleration. So acceleration of the mass m is equal to the acceleration of the mass small m. You can call it just acceleration a. Okay. Now the first thing to do for the masses is to draw the free body diagram. We can draw the free body diagram of the masses. So for the mass capital M, now the only forces, now you have to think about the forces acting on it in the horizontal and vertical directions. So this guy has tension acting on it in the horizontal direction, and normal force and weight. Okay, so here you go. The free body diagram is this. So this is your x-axis, this is your y-axis. You have tension going this way, normal force over here, and weight over here. So let's call this W1, let's say. Okay. Now for the small mass M, the free body diagram is this. Now there are no horizontal direction, there are no horizontal forces on this mass. It's hanging mass, so there is tension going upward and weight going down. So you get tension, weight. Okay. Now tension in the string is the same also. So tension over here is the same as the tension over here. Okay, that's another constraint in these systems, that the tension is also the same, and acceleration, as we've already said, is the same. Okay, so let's call this guy W2. Okay, so now let's write Newton's second law for the two masses. Okay, so for this guy, now the mass is moving in this, so the mass is moving in this direction, this mass is moving in this direction, and this mass is moving in this direction, right? So so for mass capital M, we get T equals capital MA. That's it. So that's the equation in the horizontal direction. In the vertical direction, N, so this is your X equation, and in the vertical direction you have N equals W1. So that's your Y equation. So it's simple in this case. For this guy, we just have a vertical equation. So we get, now it's moving in the downward direction, right? It's moving in this direction. This guy is moving in this direction, right? So the acceleration of both are the same. So we get W2 minus T, W2 minus T equals, so we're calling this small m times the acceleration A. Okay? So this is your one equation. Okay? So now let's call this equation 1 and this equation 2. So now you can plug 1 into, or you can say you're adding the 2, same thing. So that we need our answer in terms of in terms of the most simple or most obvious variables in the system. So we know these masses, and we know the weight, of course. Therefore, like we know the value of G equals 9.8. So we need to get rid of tension, in other words, right? So we can you can write plug 1 in 2. So we get W2 minus capital MA equals small m times A. So we need to find acceleration. So you get A equals W2 divided by M plus capital M, where W2 is the mass of this guy, the hanging mass. So it's mg over, so it's mg over M plus M. Okay, so what I've done over here is just to simplify this. You bring this term to the right hand side, you get M plus M, and then you divide both sides. So you get W2 over M plus M, and then W2 is mg. Okay, so W2 is mg. Now you can think about your results also. So you can see that they make the result makes sense. So this small m is the reason the system is accelerating. So if m is 0, there won't be any acceleration. This guy's pushing this other mass, so there's acceleration in the system. So if m equals 0, acceleration is 0. So that the result makes sense, right? So and we can now plug in the numbers. Since m is equal to, small m is 2.1 kilograms and capital M is 3.3 kilograms. From this we get, and G is of course 9.8 meters per second squared. We get A equals 3.8 meters per second squared. So that's your answer for the acceleration. Now in order to find tension, you can go back to equation 1. Equation 1 is T equals capital M times A. So capital M is 3.3 kilograms. So you get so that gives you around 13 newtons. So that's your tension. Okay. So that's it for this question. If you have any questions regarding this problem, post it in the comments, and thank you for listening.